Record. Yes, now we're recording. So I just copied and paste the P values from the experiment and the corresponding elongation. For stress, the equation is given on the right side on the note section. For stress, it's P over A. So I select the P divided by cross-sectional area. And then if I drag down this cell, there was one mistake because I should have locked this cell because cross-section area is not changing during the experiment. That's why I get these errors. Once I change this, automatically calculates the stress results for each corresponding loading. So these are on PSI actually. So to change it to KSI, that's the unit that I'm going to use. I should divide it by 1000. So it's 5 KSI, 10 KSI, 15 KSI, 20 KSI. I can also format these cells if I need to format, make it clean. I can reduce the decimal to 1 and it's more clear. For strain, you get the equation, elongation divided by gauge length. So elongation is here and the gauge length is given 2. So you come here, select the elongation divided by gauge length. And since gauge length is not changing over time, I will lock this cell so it's not going to change in the formula. And calculate all the strain values corresponding to stress. Any questions so far on this? This is pretty straightforward, right? All good. So this part, stress at fracture based on the final cross-sectional area. So in this equation, I should select final cross-sectional area, and final cross-sectional area is calculated based on the final diameter. So in this equation, again, 3.14 pi d square. In this case, d is 0.369 divided by 4, 0.11. So area is reduced about 90%, cross-sectional area at the end of the experiment. And look at this cell, it's already calculated for me. And if you look at the equation, it's P over A. P is the final load, and E4 is the final cross-sectional area. And ductility is already calculated for you. It's the final length divided by gauge length. Overall gauge length multiplied by 100. It's just a percentage, 36%. So now I have to determine Young's modulus. For this, I had to first generate the graphs, and they are already generated with the table, with the graphs provided in this spreadsheet. So this is overall steel specimen stress strain graph. This is a big picture where you see the linear portion. It's pretty linear. You can see, but when you look at this, the zoomed in version, there is small changes on this linear portion of the graph. That's why we had to use the 0.2% offset method to determine what is the yield strength. Once we determine the yield strength, the slope of this line is going to give you the modulus of elasticity. So from this graph, I know which one is the fracture strength. I have to manually enter this value, 129.76 KSI. If you pull up the files, there was a sample file for sample reports, sample calculations. You see on this graph, I have the fracture strength based on the original cross-section area. That's already given. Once you calculate the stress and strain values, this graph automatically comes to you. Once you get this, then manually you will enter fracture strength based on the neck cross-sectional area. You're gonna draw a line, and that line is gonna correspond to the stress value on x-axis and the strain value on the y-axis. Because the strain is not changing at that fracture point. So ultimate tensile strength, whatever was the maximum load applied, in this case is you got to change this value because this is not the max. $91. This is the max. Correct me if I'm wrong. So this is your max, and this is your maximum ultimate tensile strength, because this is the maximum value in this table. Are we good so far?
You're gonna say something for this project or test. Whenever you wanted us to calculate when it comes to be the cross-sectional area or the final cross-sectional area, the P formula will give us a small kind of different number from what we.
Yeah, that's fine. I'm just putting 3.114, and whatever, if you use the pi from the Excel, then that's the most accurate one.
Okay, thank you.
3.14, I just remember that number and I use it because it's easy instead of writing the equation for pi. So whatever the result that you get, that's the correct one, as long as you use the pi.
Perfect.
Okay.
Will you take points off if I, because I added the notes, that little square that says notes into my report. I don't know if that will cost me.
No. It's not gonna. It's just the notes, and you should have this information on your reports.
Okay, perfect. Thank you.
So in your theory section of your report, you should define stress, strain, and modulus of elasticity, yield strength. These are definition. You should define them in the theory section and write down the equation that you are going to use on your calculation. So let's look at the sample report. We weren't able to look at the sample report last week because we didn't have time to go upstairs to the room. So let me pull up the tensile report. So in the objective part is the same for all of you. So you can just copy and paste the same thing because it's given to you. The objective of this experiment was to determine the yield stress, the strain, the modulus of elasticity, and the ultimate tensile strength for the steel and aluminum metals. That's what we're trying to calculate, and that's what we are doing right now on the spreadsheet. The other objective was this experiment to determine the relationship between the stress and strain of two metal specimens. That's clear. So we're just comparing two different materials and looking at the characteristic of these two specimens. Equipment is the same. TIN is also an UHTM, and UHTM stands for Universal Hydraulic Testing Machine. That's the machine, it's not working. We're trying to figure it out what's wrong. And specimens, steel and aluminum. Extensometer is used to measure the length, change in length. And micrometer is used to measure the diameter of the specimens. And gauge punch is used to punch two holes that shows the distance. Actually, that shows the gauge length, 2 inch. And ruler, we use ruler to check the dimensions. So in theory part, like I said, the definition of stress, how to calculate the cross-sectional area, strain, and modulus of elasticity. And in procedure, in my previous video, I covered the visual testing procedure. There was a link on Moodle for virtual lab. You can use that as a procedure. And there are a few videos that I uploaded. You can check those videos that shows the procedure for steel or aluminum tensile testing. This is the data and results section. That's why you're going to use the tables and graphs that you generate on this spreadsheet. This one. This one. By the way, you should have fixed this graph because in this graph, I have to add more data points to see where graph is curving. And that's when I can use this graph. Now we'll get that. So you should include these graphs on your data and results section. Obviously, your table goes into your report. On the table, you should only show one Young's modulus. I don't want to see more than one Young's modulus. So in theory, this slope on this linear portion, we assume that the slope is the same in the linear portion. But since we are doing real experiments, slope is not the same. But in theory, we assume it is the same. So you should have only one Young's modulus. If you type what is Young's modulus for steel, it's going to come up 29,000 KSI, because there is only one Young's modulus for steel.
I might have missed if you said it. Did you extend the due date for the report?
No, I did not extend the due date for the report. There was only one exception for one student. Okay. I failed to respond on time, and
okay.
And I gave him 2 days extension, and he got the answer.
Okay.
But if you feel like you messed up on your report, just give me a heads up. I'm explaining step by step right now again how to develop your report, and you can use this this class as a reference for your next report. So concrete report is going to be the same. So it's going to be constructed in the same way.
Okay. The only issue that I had, which I mean, I guess it is what it is. My report's been turned in. I think I used the wrong test data. I know you said that there were duplicates.
But that's
the
fine.
diameter.
That's fine. That's okay.
Okay.
I mean, I just look at the numbers. As long as the result is not goofy, like the graphs are not looking correct, then
got it.
I will let you know that something is wrong with your data and you can correct it. But even if you use the other data points, it should be fine. I'm sure that file.
You're just going off of the data that we used. Okay. Exactly. All right. Not a problem. Okay.
So Young's modulus of steel is 200 gigapascal, or 29 times 10 to the 6 psi, or 29 times 10 to the 3rd KSI. So we have only one Young's modulus for steel sample that we tested, and it should be around 30,000 in our sample. Let me see. It's 32,000. Since we are running the real tests, and it's just one-time testing, we do errors during the testing when we're taking readings and measurements. That's why it's more than 39,000 KSI, and that's why you should discuss it in your report, on your discussion part of your report, why the Young's modulus of our steel sample came out different than the one that's advertised or shown on the steel menu. It's because of the errors. So you have one table for steel. You have 2 graphs for steel. In this one, it's pretty clear. You see the plateau over here. This is different data points. So this is different steel sample that we used back in the time. In this one, yield point is 51.2 KSI. 0.02 offset method. Basically, you draw a line from 0.02 offset from the linear portion of the graph, and the intersection point tells you the stress or the yield strength of the material. And once you find that, you calculate the slope in this portion, and that's your Young's modulus. Again, you gotta show the fracture strength based on the neck area. And this is for aluminum. And conclusion on discussion. It's pretty simple to me. Any question? If not, I'm gonna jump on the concrete and spend some time on the concrete lecture. Sean, everything is good?
Yeah, I'm good. My internet connection is cut. Sometimes I hear you some,
okay.
but I'm good.
Okay. All right. So let's look at the concrete. Let's start with concrete handout. That's handout. This is the handout, and I do have the original handout over here. If you were doing in class, this is the worksheet or the handout that you should receive. Title is the concrete lab, and the objective is to prepare a batch of concrete from pre-mixed bag. This is what we did in the first lecture. We prepared a batch, concrete batch from pre-mixed bags. We made 2 samples. We should have done the testing today, but since the machine is not working, we are not able to do the 7-day testing. Hopefully, we're gonna get the machine back in operation sometime soon, so we can perform the tensile and the compression. Perform a slump test. We did the slump tests. We prepared 2 6x12-inch cylinders and perform compression tests on the cylinders at 7 and 28 days. We missed the 7 days. Hopefully, we're gonna get 28 days. But just to be on the safe side, I already have the data from previous years. So I will provide the data from the previous year. And if you run the experiment, you will just see the specimen is behaving and how it fails. So another objective is to determine and draw the shear stress and strain diagram, similar to tensile. So in theory sections, we have the stress equation, P over A, same, load divided by the cross-sectional area. For strain equation, it is delta L over L. It's change in length divided by the original length. And modulus of elasticity of the concrete is stress over strain. It's the change in stress divided by change in strain. And there is another way to find the modulus of elasticity for concrete. This is the equation for the modulus of elasticity. It's established by ACI, American Concrete Institute. 57,000 square root of F prime C. So once we calculate F prime C, which is the concrete compressive strength, we believe that it's 4,000 PSI. That's what it says in the concrete mix. So if it's 4,000 PSI, you will input 4,000 PSI and solve this equation to get the modulus of elasticity for your concrete batch. And you can also get it from the graph. And I will show you both ways. So you can compare. They should be similar number. It also says that over here, I didn't complete the modulus of elasticity section. It is only applicable at F prime C when stress is at F prime C over 2. So let's say F prime C is 4,000 PSI. It is only applicable on below the 2,000 PSI region. So you can only look at the ratio between stress and strain below the 2,000 PSI. And you will see how to run these numbers once we look at the data points and once I go over the sample report as well. So this is the table that you need to have on your report, and I have the template on Moodle. I might not have it at this moment, but I will upload it. I don't have it here, but I will upload the template as well. So you will have two tables. You will be given the data change in length during the experiment. This time it's not going to elongate, it will get shortened because of the compression. And you will have the corresponding load for 7 days and 28 days. And you will calculate stress and strain same way. Then you're going to have your graph. In this picture right here, this is how graph is supposed to look like when you finish your report. If you're looking at 4,000 PSI concrete, you have your x-axis for stress in PSI up to 4,000 PSI. And this F prime C 28, it stands for the compressive strength of the concrete sample at the end of 28 days. And you have F prime C over here, 7 days. And that's the maximum compressive strength that you get from the concrete sample at the end of 7 days. Once you enter the data points, you will have your curve. But we're gonna do some manual calculations at the end, because at the end of the experiment, if you look at the videos, there are a couple of videos that I posted on Moodle already. At the end of the experiment, before the failure, we take the compressiometer out before concrete fails, because if concrete fails, that gauge is going to fail as well, but we cannot waste the gauge for each testing. So we take the gauge out, so we don't have the final reading for the deformation. That's why we're going to be missing one data point at the end for strain. But since we have the final load at fracture, at failure, we can get that strain value from the graph. We can read it with the corresponding stress value. Now we'll get there when we start looking at the data points. But that's going to be next week. So let's look at the model. So we look at the concrete handout, original handouts. And this handout, this is important, and I highlighted for you guys to only skim through and look at the important section of this handout. And you should include and summarize this handout for your theory section of your report. Obviously, you should explain what is concrete, what is it made of, and it's made of sand, gravel, crash rock, and other aggregates. We saw it during the first portion of this lab. And I mentioned the admixtures. Sometimes one or more admixtures are added to change certain characteristic of the concrete, such as its workability. To increase the workability of concrete, I would mention that how we can make it fluid without adding more water. You can have admixtures or chemicals to change the workability. We can also use admixtures to increase the durability of the concrete, and we can add admixtures to change the time of hardening, because we want to be ahead of the game, and we want to gain strength at early stage of the concrete. So in that case, we have to use different admixtures. And in this handout, you can see different type of admixtures and why they are used for, and you can see the cement types. All you have to do, just read over it and then summarize it on your theory section as a background for the concrete report. These are the admixtures. So make sure you take a look at this file. Before sample concrete reports. This is another one, so you know what we use in that in the first lab. This was the concrete mix that we used. We used 80 pounds. And you can see why it's used for. Product use is for foundation walls, footings, sidewalks, curbs, steps, ramps, and walkways. You can find this for 40 pounds, 60 pounds, 80 pounds bags, and we use the 80 pounds, and it tells you the yield. 80 pounds bag yields approximately it's 0.6 cubic feet. That's how much you get again. And you can see the technical data, and we are actually interested in this section. So we're going to compare our results from our data points from our testing. At 7 days, it says compressive strength according to ASTM C39. 7 days, we are expecting to have 2500 PSI. And at 28 days, we are expecting to have 4000 PSI. We usually go beyond this number, but I don't know the data points that I'm going to give you guys. I'll have to check the numbers, but it should be beyond 4000 PSI. So you should compare these numbers at the end of your report at discussion and conclusion part, why our number was different, etc., etc. And slump range is 2 to 3 inch. I believe our slump was more than 2-3 inch at the beginning, and then we adjusted to 2.50, 2.75. So when you're buying concrete, you can look at the specs first and pick your concrete based on the product use, what you're gonna do with this concrete, and you can get the technical information about the strength of your concrete from the specs, as long as you follow the procedure. It tells you step by step how to mix it, water content, final water content, everything. So the most important information was at the first page, was the specs. So this was from a couple of years ago from my job site. I don't know if I can rotate it counterclockwise. This is the receipt from Lafarge Concrete Company. So when you look at the receipt, there are a couple of important points that you have to look. What time the concrete truck left the facility. It should be somewhere here. I know it is at job site at 1 p.m. and it said it's due at 1 p.m. and it is somewhere over here. If you guys see what time, 12:18. So there's 90 minutes limit. So if the truck is late more than 90 minutes, then there's a problem because concrete starts sitting after 90 minutes. So you have right to refuse this order. First, you check the time, what time it left the facility, and what time it arrived on the field. That's the first thing that you check. And then if you look at the quantities, cubic yards, and slump, 4 inch. So you have the slump, it says 4 inch, but you gotta double check it when you get the concrete mix. From the first batch, you check the slump, see if it's 4 inch, as it is stated in this receipt. And also you have the 3000 PSI strength on this concrete. You take your sample and then you get the testing done. It will take a few days to get the results, but still you have right to compensate from the Lafarge or concrete company if there is something wrong with their receipt. That's what you do if you're on job site. So you do the slump test, check the time, and then take a sample.
All of that done before pouring? So the sample, when you said, I know you said there's 90 minutes from the time the truck leaves their facility to when it gets to you.
Right.
90 minutes, is there some type of error time built in, or is it like at 90 minutes that concrete needs to be poured?
90 minutes concrete needs to be poured, and in some cases they add sugar. You can search it. Concrete, if you add sugar, it increases the time of hot setting. Why sugar is added to concrete. So sugar is actually a well-known retardant concrete, and is often used to help to adjust setting times, especially in emergencies. In the case of sugar, setting process is slowed down because it interferes with the chemical reaction that causes cement to set when the water is added. So it basically delays the setting of concrete if you add sugar. So let's say you are going beyond 90 minutes, you can add sugar, and there are different admixtures, you can increase the timing, but it has to be on the receipt as well. So if there is something extra on the concrete that you don't know, then that's the problem. And if it's over 90 minutes and they don't have the admixtures, they don't tell you what's going on, and they just want to add more water or more extra stuff in the concrete, that's going to be beyond the scope of this specs given by the engineer. So it depends from the project to project. So in this one, the limit was 90 minutes, and this is 3,000 psi regular use concrete. If it's big scale project, then it might be a different case. But did you get your answer for the emergency situations?
I did. Thank you.
No problem. No problem. So far, we know what concrete is. We know how to manage it, how to mix concrete, what to do on job site, and what kind of test we can complete. We know the theory section. So only thing is missing over here. You also have the videos you can watch. Only thing is missing is the template and the data points for concrete. So once you have that, I'm gonna try to upload them today or tomorrow, ladies. And this report is not due next week. There is no report due next week because concrete report consists of 3 pages. The first one was the concrete preparation, and the second one is today, 7-day testing, and then you wait 21 more days to get the last testing results. So it's not due next week. I will update the data for 7 days, and you start working with the data, and you can start working on the theory section of your report. You can start typing it. And if you look at the sample report, that's going to help you how to develop the theory section and the experiment of the concrete. I'm not going to go over paragraph by paragraph. I explain on the tensile testing, it's similar. The equipment used is going to be the same. And objective is the same. This objective is the same as that I show in the previous handout, the first handout, handwritten one. Experiment is basically it's the procedure. You can use the pictures from the handouts or notes given to you. I will try to add more notes for your reference. And citation is required. Just you have to cite, use citation at the end of your report. Since this report consists of 3 phases, it's a combination of 3 lectures. This report should be longer than the other reports. So you should spend more time on this report. So you should elaborate the theory section and the procedure and get in the details. Procedure is the same that is on the handouts. Slump procedure, you can look at, that was one handout for slump. Slump test right here. Tells you definition of slump, concrete slump test, equipment use, and procedure, step by step. You just summarize it, and you observe it in the first lecture how to perform slump test. Sorry. There you go. So once the procedure is complete, then result section. So if I update the 7-day data points, you can start working on your table, on your calculations for 7 days. You will get these first two columns, delta L and P. Then you will use P over A stress equation for the stress calculations, and strain equation is delta L over L, same. So you can finish this 7-day result, and you will wait for 28 days. Once you get to 28 days, you will perform the same calculations for 28 days. All these data points will be given to you. And you're gonna have your graph. You will have only one graph, and it will consist of 2 different data sets, 7 days and 28 days. So if I look at one graph, I'll see what is F prime C at 28 days. It's about 44,000, 43,000, 43,000 right here. Okay. And I see the compressive strength at 7 days, 2,200, 2,200. This is the picture of UHDM when it was working. We use the lower portion of the UHDM for compression, and the upper portion is for tensile testing. And on discussion and conclusion part, you will just compare the theoretical values that is on the specs here with the experimental values. We'll talk about the stress and strain and Young's modulus of the concrete. That's it. So let me answer questions in 5 to 10 minutes. And if there is no question, we can call a day. And I will update the model soon. Any question?
So you said that you're gonna put a chart, like the Excel chart up for the concrete. It's not up there right now, so you're gonna for Moodle.
This is the concrete compression test results for 2024, last semester. So you're gonna see similar table, similar graph. Basically, on my template, I will just take out these sections, and you will have to fill out these sections by using the equations P over A and delta L over L. Expected results: 4,000 psi, 2,500 psi. This is modulus of elasticity calculation at 7-day and 28-day. It uses the equation that I mentioned in the first handout, 57,000 square root of F prime C. You have the definition. I will actually post this one since I have it. We have the definition over here for modulus of elasticity and the derivation where it's come from. Diameter, we already measured the diameter of the cylinder, 6-inch. Cross-sectional area is same. I use 3.14, you use pi. If you use pi, that's most accurate. Length was 12-inch. And slump is 2.75. And I believe our slump was around 2.75. So you will enter the slump. The diameter is already there. And I will update this section for you. You got your answer, Noah?
Yes, I did. I just want to make sure.
Yes. Okay. I was gonna go over this one as well. Forgot, but once you start actually working on the 7 days, and once we get to 28 days, I will have another section to explain the graph and the table. But if you are able to do the tensile test and report, that's pretty much same. You will have 1 or 2 questions when you come to end to determine this strain values at the end of the experiment, because once you remove the strain gauge before the failure, you can't get the last reading. So you just need to look at the graph and then take the reading from graph. This is estimating. But other than that, it's just simple calculation, two equation. You think? All right. Any other question?
Well, you have this recorded, right? This class period?
Yes, I do. Yes,
Okay, all right. And you'll post it up on Moodle?
Yes. I
Okay,
do.
all right,
No
thank you.
problem. So if there's no question, then we can call it a day. It was nice seeing you guys. Hopefully next week we're gonna do torsion. So on torsion, I'm expecting to have in class because Tuesday we run the torsion testing. Mr. Landry Byron was there, and he is the one operates the torsion. The machine is running, so hopefully he's gonna be there on Thursday. We will run the torsion testing in class, and we will get an update on the UHDM if she's gonna make it or not. Okay. All right then. It was nice to see you guys again. I will see you guys next week.
Okay,
You will
thank you,
post
sir.
this video anytime soon today?
Yes.
All right,
anytime
thank you.
As soon as the video is converted, I will post it.
All right, thank you so much.
No problem. Bye bye.
Have a good day.
You too.